Hi, and welcome to Courtroom is in Session, or Intro to Hypothesis Testing. Our essential question is, how can I distinguish from random variability? Go ahead and take a look at the right side about the wildlife scientist looking at a species of frogs to determine whether you believe the given information shows enough for the scientists to be alarmed, fearing that the environment may be affecting the frogs. When you're ready with your answer, go ahead and start the video again to see if your answer is correct on the next slide. All right, so here is your answer. So notice it says that the average for 50 frogs is around 119, give or take. Notice you have a sample standard deviation of 14, and then square root over 50 because of your sample size. From there, go ahead and determine a z-score because you found that your sample mean weight was 110 grams. So we want to know, okay, well, is this unusual? Turns out it is because the z-score was negative 4.04, which was a very small chance percentage. So what I said is it seems like yes, it seems very unlikely that my frogs would have a mean weight of that, at least given the information. So I've got some reason to suspect something's maybe going on with the environment, or maybe I need to look back at how the sample was taken, et cetera, et cetera. So this idea that we just discovered here is critical into understanding something called hypothesis testing. So let's take another situation. Let's say I take a deck of cards, I shuffle them, and I ask you to draw a card. I just want to know, well, what are the chances that you draw a red card? Hopefully you said 50-50 because, well, half the deck is red, so 26 out of 52. So let's say you keep that card, and I want to know, okay, well, what are the chances that you draw 2 red cards in a row? So again, you're not putting that card back, so really be careful how this works. Well, hopefully you have 26 out of 52, and the next one, now there's 25 red cards and 51 cards total. All right, still not really unusual. Okay, draw a third red card. What are your chances now? 12%, not terrible. You might just be really, really lucky. What about 4 red cards in a row? Getting smaller and smaller, I see. So here's the thing. Let's say you actually drew 5 red cards in a row. You might start to suspect something's going on with the deck. Well, here's the problem. We initially assumed that, well, half the deck was black and half the deck was red, or the proportion of red is 50-50. The question is, well, what would be the opposite of that? What would the alternative to that idea be? Well, probably that the deck is not fair. Something's going on. It's not quite right. Or the proportion is not, in fact, 50-50. It's something else. Here's the thing, though. If you drew 4, 5, or even 6 red cards in a row, let's say that actually happened, you might want to suspect that maybe the deck is not a standard deck. There might be something going on, especially since the chances of getting 5 red cards in a row is so unlikely. There's enough evidence to suspect something is not quite right. Congratulations and welcome to hypothesis testing. You're taking something to see how unusual what you just saw, of course, assuming something is true. So obviously this is a method that will assess your evidence, obviously, of the reporting the probability of the claim actually occurring by random chance. So the evidence that you're using is something called a p-value, which, surprised, you just calculated on the previous slide with obtaining 5 red cards in a row. And the biggest general term, this is crucial, is p-value is the probability of obtaining the statistic or one more, even extreme than that, by either natural sample variation or by random chance in the layman's terms, given the claim is actually true. So here's the thing. Confidence intervals offered a range of plausible values for the parameter. It's somewhere between here and here, kind of like a net. You're trying to catch the fish. Hypothesis testing is kind of the other side of that coin. It assumes something is true, tests to see whether what I saw is actually consistent with that claim, and then we determine if it's unusual or not. So here's how the basics work. You start with, obviously, a hypothesis or the claim. And it's usually called the null hypothesis. And you're always going to be assessing the strength of the evidence against the null. You always assume that the null is true. And unfortunately, it's the dull one. It's what you expect to be true. It's nothing is fishy. The die is fair. The coin is fair. The deck is half red, half black, things like that. The other one is called the alternative. It's usually what you suspect is true or something you're interested in finding out. Maybe there's more red, so the proportion is more than 50-50. Maybe I just want to know, is it not fair? So proportion is not equal to 0.5. So take a look at the following scenarios and determine if you can write the alternative and the null hypothesis for each. The first one, read carefully. Hopefully you said for the null that the average is 26 miles per gallon, that the brand of oil isn't increasing the mileage. It's dull, nothing new, nothing exciting is happening. Hopefully you read very carefully to write your alternative, that it's higher than 26 because it wants to know it's increased the mileage. Take a look at number 2. So hopefully null dull, you said the proportion is 0.72. It's not different. It's not any suspicious. And then just not equal to, because you just want to know, would it be true for a local high school? Doesn't really say higher or lower, so we just say not equal to. Similar to the last one, has the percentage changed? Notice it doesn't say higher or lower, so we just say that, well, it is at 40%. Nothing's changed, it's dull, it's boring, nothing fishy going on here. Alternative, it is different. So how do you know whether you have passed the test? Well, if your p-value is high, we fail to reject the null since what we just saw is likely given the null is true. For example, getting 2 red cards in a row. You probably wouldn't suspect anything is fishy about your deck. So think of this like a courtroom. So you never claim that a person is innocent. The jury will never come back and say, oh, we think the person is innocent. Oh, no, no, no. You always say that they are not guilty or they fail to find the evidence to actually convict. Same idea there. So on here, the p is low, you reject the null. Since what you observed is so unlikely, there's no way the null was true. I just got 7 red cards in a row. I would probably reject the fact that the deck is fair. Or man, I just rolled a die 10 times and got the number 2 all 10 times. The die, honey, sorry, you're not lucky. There's probably something wrong with the die. Easy way to think of it, if the p is low, you reject the hoe. At least that's how I remember it. Obviously, you would never, ever in your life, both on the street and in statistics, accept the hoe. You never accept a null or an alternative. You just fail to find the evidence because later you're going to understand that there's obviously a chance that we could be wrong. I would take a look at this video, Legal Statistics. We don't really have time, but the link is go ahead and hover it up there. I recommend if you'd like to see this in courtroom, see how it actually works in this scene from Legally Blonde. In each situation, there are incorrect setups. Go ahead and pause the video to see if you can find why these are wrong. All right, and the first one, hopefully you said mu for the parameter. X bar is the part that is wrong. You never ever have a sample statistic. You're always trying to understand the null, which is mu. You understand the parameters. Hopefully on the second one, you notice 2 things were wrong. The p should be p, not p hat. Also, it should be equal to 1 out of 6. Again, null is dull, nothing fishy. The last one is multiple choice. Go ahead and kind of take a look and see what you think about this. So it wants to know which conclusion is appropriate. Hopefully you said the answer was D. So again, there's a 3% chance that a fair die could produce the results I just saw. So it's reasonable to conclude that something's fishy with the die. It's probably loaded. Hope you enjoyed this first video. Feel free to watch a few more to understand hypothesis testing.